So hi everyone, I'm Mark Dijker, the developer advocate at Digrid. And with me is Josh. Can you introduce yourself, Josh?
Yeah, hi everyone. Yeah, I'm Josh. I'm a software engineer here at Digrid and a core maintainer on the Dapper project.
All right, excellent. So let me start with sharing my screen. Moving some stuff about. All right, so you should see the blog post that I written like a couple of weeks ago about Dapr 1.13 release highlights, because Dapr 1.13 was released in the last week of February. And that's what we're going to talk about in this webinar. And Josh is here because Josh, you were the release lead of Dapr 1.13, and well, for me that was like a completely new term when I joined the Dapr OSS. But so maybe you can explain a bit what it means to be like a release lead for a release of Dapr.
Yeah, exactly. Yeah, so a release lead for Dapper, and this is probably true for other open source projects. I'm thinking Kubernetes and things like this. So release lead primarily is a project management type role. So the kind of responsibilities of that person is more of a kind of organizational kind of role. So you're responsible for making sure that issues being tracked and you're following up on work being done, helping to facilitate conversations to set priorities and things like this. It's certainly not a dictatorial role. You are there, primarily for the kind of facilitation and making sure people are speaking to the right people and yeah, connecting people together and things like this. And then yes, towards the kind of end of the release, you are then responsible for making sure the boxes are being ticked and pipelines are passing and things like this. And again, speaking to or connecting the relevant people together to make sure things are running smoothly. And then, of course, yes, at the very end, clicking the button to get the release out. So yeah, it's a bit of an overview of the role.
Thanks, man. And yeah, and really, you did an amazing job, right? Because this was like a long release process. It wasn't easy. So yeah, it must be like probably feels like a lot of like herding cats as well, right?
Yeah, there is yes, I think herding cats is a good way to describe it. And yeah, I think the herding cats. I think anyone who's done any kind of project management role, yeah, in any position would probably herding cats probably, yeah, sounds quite familiar as an experience. Yeah.
All right. Okay, let's move on to the release highlights. So what we're gonna do, we're just gonna scroll through this blog post, and we're just gonna highlight a couple of things. Out of this, I'll show a couple of code snippets. Maybe run a couple of things. Definitely not everything. Just to give you a bit of a taste of what's in Dapr 1.13. And I'm very curious, maybe for the people here attending this call, let us know if you're already using 1.13. Maybe are you already like starting to play with it? I'm very curious. So let's gonna scroll down a bit, and let's start with the with the APIs, because this blog post usually starts with what kind of new APIs are there, or what kind of new has been added to the API building blocks of Dapr. And one of the things that is new, that we can now author workflows using JavaScript / TypeScript and Go. So Dapr workflow is still a relatively new API in Dapr, and it was introduced like a couple of versions ago, where you could use like .NET to author your workflows, and then Python was introduced, and then Java, and now JavaScript and Go are added to this as well. And let me, maybe before we look into the TypeScript and Go, let me briefly head over to the new Dapr slide deck, which is available on the Dapr docs, by the way. For people not familiar to workflow, describe what it is. Oh, this is the wrong screen. I don't want this. Can I move this around? Let me see. The zoom bar is, of course, in the way. Okay, we'll do it like this. So if you're not familiar with Dapr workflow, it's like an API that enables like durable execution of potentially long-running business processes. So just to give an example, maybe your application starts by receiving a message from another service, and then this workflow then kicks off, and workflow consists of different activities, and in these activities you typically call like different endpoints, or you retrieve some state or save some state. So this is an example that also involves like different Dapr APIs. So in this first activity of this workflow, we get a secret using the secret API of Dapr. Then one of the things that workflows can do is a workflow can wait until an external event has been received. So this is quite useful in certain approval use cases, for instance. You can also execute multiple activities in parallel and then aggregate the result. So in this case, we have activity B and activity C both doing different things, but maybe they're like also collecting some data, and we can aggregate that data back in the workflow. And then we have an activity D that publishes a message to a topic. So typically, what you do with workflows is you use have one of the different workflow programming patterns, such as task chaining. So this is where the order of the tasks is very important. So just an example, we have like calling A and B and C, and because maybe the output of activity A is used as input for activity B and so on. Another example is like fan out, fan in. So that was also part of the example earlier. So we start with maybe an array of different elements, and then for each of the items in that array of elements, we call the same activity, or we call like different activities all with the same input, and then aggregate the result before we return. Very powerful. Another pattern is the monitor pattern. So this is like a recurrent activity that you can do. So you execute an activity, and maybe you call out to another endpoint. Then you instruct the workflow to introduce like a delay, which you can do with a timer, and then you instruct the workflow to continue as a new fresh instance. So this is very useful for like daily or nightly jobs that you want to execute. And the final example is the external system interaction, and that uses the weight that we also saw in the example. Very typical for like, you need some kind of approval in case you want to maybe buy something that's above a certain expense limit or something, or maybe you want to get an approval for your holiday. So you have like an activity to get an approval, so that maybe calls out to another application where your manager gets notified, and then your manager needs to do some interaction, which essentially will involve some kind of event that will be sent, and it will be received in this service. And once the event has been received, then the workflow will continue. It will inspect the payload of the event, and then it's either approved or not approved. So with all these workflow building blocks, you can create some really nice features in Dapper now as code. So let's have a look at some two examples that are in the quick starts. So let's head over to the Dapper quick starts repository. I'm in the workflow folder here, and as you can see, we have now quite some different language examples. So one of the new ones is Go. And if you have a look at this workflow.go, this is the definition of our workflow. Let's scroll all the way up here. So here we see the function that contains the workflow itself. I'm not going to read through it line by line, but just highlight where some activities are called. So for instance, we use the workflow context to retrieve the input that was sent to this workflow. And we call out to an activity called notify activity, and we give it a payload. And then we await it, and we only continue with the workflow until we have received the result of this activity. Then we call out to another activity to verify the inventory. So this is like a typical like a order process sample. And again, we await that, and then we inspect the outcome of that, verify inventory result. And if that's not a success, then we do again a notify activity, and we return a processed false as the output of the workflow. And this is like the example that I said earlier. So if there's a total cost which is higher than a sort of a given value, which is like hard coded here for a sample, we would request an approval, and then we would wait for an event. So this activity here, the request approval activity, would then reach out to like a different endpoint where a manager then needs to perform some sort of action, which would result in an event that is then received by this workflow. And once that's received this event, then the workflow will continue. Let me scroll down a bit too, because it uses all of the same activities. So there's a lot of notify activity calls in here. So that's all the same. Let's actually move down to some of the activity definitions. So that's here. So these are some examples of the notify activity, which just does like a print statement. And then there's like a simulation of a process payment. So again, that takes some input and does some print statements. The verify inventory activity actually does a bit more. So here we are seeing that we're creating a new Dapper client instance, and we can actually get the state. And we are mentioning a state store name here and an item name. So here we're actually using the Dapper State Management API to retrieve a key value pair to assess if the inventory is sufficient. And let's see, there's also like an update inventory activity. Well, you can probably imagine what that's doing. Again, we're using the state management API here of Dapper to retrieve some state and also to save some state. So I think this is like a nice example that shows both Dapper workflow, but also the Dapper state management API. So that's what I find very nice of Dapper workflow, is that you can combine that with all of the Dapper APIs. So let's run this. Let's see if it's actually working. I need to use this folder though here. So this folder contains like a Dapper YAML file, and this contains the instructions what to run. So I'm using Dapper CLI with multi-app run. And so when I do Dapper run -f dot, this file will be picked up. And in this file, there's a reference to a resources path that points to the components. And it will actually start an order processor in this folder. So what we should see is a lot of log statements about this whole ordering process that will go on. And there are also some delays introduced. So initially, some stock has been added to the inventory, and now we see all this notify activity being called. We see the verify activity being called. We could request approval, process payment, and now here we see that the workflow is actually completed. All right, this is like a quick example of the Go quick start. Let me stop this. All right. And so the other new one of workflow is JavaScript. So again, there is in the quick start repository in workflows and JavaScript /SDK, there is the same order processor with again a workflow here. Oh, I actually forgot to mention some stuff for the Go one, because I did show you the workflow itself. But before you can actually run the workflow, you also need to register the workflow. And I forgot to mention that. So that's actually quite important when it comes to workflow. So let's go all the way to this main Go file. There should be something in here. Yes, here we go. So for every application, every language that implements the Dapper workflow, you need to register the workflow, because as soon as the application starts and the Dapper sidecar is there, the Dapper sidecar will check what kind of information is in your application. So if you don't register the workflow and all the activities, Dapper is not aware of that your application is actually using some Dapper workflow. So that's why you need to register your workflow and the activities in your startup code. So that's the same for every language that you need to do that. Of course, how it looks like is of course language dependent, but the process of registering workflows and registering activities, that always needs to be there. So we're registering the workflow, and here we are registering all of the different activities. Right, going back to the JavaScript one. So the JavaScript one also has the same process. Also, we are registering the workflow here, and we are registering all of the activities. You can briefly have a look at the JavaScript example, but it will be, again, a lot of the same things. But in this case, we start at the top by the implementation of all of the activities. So this is the notify activity function. Then there's the reserve inventory activity that again also uses the Dapper client state management API to get some state. Then there's the approval activity. It's just like a hard-coded one. Simulation of the payment process. And then we have an update inventory activity, which again uses the state API to actually get some state and to save some state. Then we look at the workflow here. So this is now TypeScript, right? So we're actually using using the type system, which is nice. So we're inheriting from T workflow, one of the base types here that you're using. And this then contains all of the call activity steps. So here we are calling out to the notify activity, and this is then the payload that we give it. Here we call out to the reserve inventory activity, and based if it's not a success, then we do another notification indicating why it's not a success. Here we have the same thing. We determine if the total cost is higher than a certain number to do the request approval thing. And here we do like the simulated process activity. So it's exactly, well, I think it's like almost exactly the same as the Go example, but then for JavaScript. Right. Let's move back to the blog post and then to the next example. So we've seen the TypeScript example and the Go example. And the next thing what is new is we can now author actors in Rust. I do have the code for that as well. Let's have a look. So this is the Rust SDK of Dapper that contains an examples folder with, in this case, actors. So there are two files there, client and servers. Let's first have a look at the server because that contains the definition of the actors. So that's this part. So this is the, let's say, the actor interface. I'm not familiar with Rust, so I probably use different terms here than I should use. But then here's the implementation of my actor, which has the do stuff method. And it's using some actor methods to actually get some state. And here we can actually see that the my actor is inheriting from the built-in actor type, and we are actually overriding some of the methods. And so whenever an actor gets activated, you can actually execute a bit of code there. So in this case, we do like a print line to actually show that we are activating an actor. Same for deactivating, and some code that you can execute when reminders are triggered or timers are triggered. Anything else needing to know? Oh yeah, so yeah, as before, also the same for workflow, but also for actors. When you're working with actors, you also need to register actors. So in this case, we're also registering actors here of a certain type and a certain name. And in this case, we're also registering methods. I have not seen it before in other languages, but in this case, for the actor one, you can also register methods to be called from a client. So this is then the client code where we deal with the actors. So let me see. So here we create the Dapper client, and here we use the Dapper client to invoke an actor. So this is the type of actor. That's my actor. This is then the ID of the actor, A1. This is the method that we're invoking, and this is the payload. All right, I'm not running this up because I don't think I have all of the right prerequisites here. But if you're doing Rust, please give this a try. I mean, Rust is let's say still like a work in progress for the SDK. It's not stable yet, so it will be nice to have like another pair of eyes to test this Rust implementation. All right, back to the blog post. Okay. Yeah, so just so I can definitely use your help a bit, because now it's a lot of hard stuff, and I don't know anything about that. So you can definitely help me with some of the runtime features that have been worked on.
Yeah,
so,
absolutely.
So one of the new things that you definitely personally worked on was like component hot reloading. So can you tell me a bit about that?
Yeah, absolutely. So this has been a highly requested feature for years, I suppose, to say. And what it does is, previously, before 1.13, it was the case that a component, which is the manifest that you use to describe, a component to building block that you want to use from your application. So in concrete terms, this might be a pub sub component, a state store, a secret store, configuration store, what have you. It was always the case that when you installed this component, it was static. If you wanted to make changes to that component in order for those changes to take effect into your application and into the Dapper sidecar effectively, you needed to restart that Dapper sidecar. This is can be problematic, and it's not maybe the best from a kind of operational perspective. We want that to be dynamic, right? So let's say, as an example, I need to update the database connection string, something like this, update a secret, whatever it might be. I'd have to restart my Dapper sidecars to pick up the new configuration. So in 1.13, we've added a preview feature. So you do need to enable it via configuration, as it is preview, to enable what we're calling hot reloading. So if you make an edit to a configuration, to a component manifest, that's going to take effect straight away in the Dapper sidecar. And that's great. So components are implemented for 1.13. It's certainly the case that we're going to be implementing hot reloading for other resources or other resource types. So next on the list will be subscriptions. But of course, we've got other resource types as well. So I'm thinking configurations, resiliency, HTTP endpoints, some others that I'm probably forgetting. But yes, if there's a particular resource type which is interesting for you to be implemented for hot reloading sooner rather than later, we'd love to hear from you. Just to know what to prioritize first. Components, obviously, is the most popular resource type, and it provides the most value, I suppose, as the first resource to implement, and then subscriptions made the most sense to tackle next. But yes, after that, open to ideas or what we'd like us to prioritize.
Cool. Yeah, very cool. Yeah, this is really a cool feature. And I remember need asking you from, okay, yeah, so what's the benefit of the user, right, for this feature? Because I didn't fully get it, but I didn't realize that you would always need to restart your process like manually, right, or script it in a way or something. So yeah,
That's right.
Definitely like a big time saver for everyone benefiting from this. Very cool. All right. And the next one, low metric cardinality for HTTP metrics. Feel free to take that one as well, Josh.
Yeah, absolutely. So, so I can speak to this as well. So, when we say cardinality in metrics, what we're saying here is, Dapper exposes metrics as, Prometheus metrics. These metrics have labels associated with them, and we describe this number of those labels as being the cardinality of those metrics. And because the way that metrics are stored in databases like Prometheus as a time series, it becomes problematic to increase the number of labels that you have on a particular metric. The kind of storage size increases, and querying becomes problematic, and things like this. So as of 1.13, we've revamped the metrics which are served from Dapper and reduced the cardinality, and whilst maintaining a high quality kind of introspection of those metrics, and producing what you need to actually monitor your Dapper cluster. But yes, this is super important for those who are consuming those metrics, and storing them in time series databases.
Cool. Yeah, excellent. All right. I did spot like a small indentation error here. I mean, this HTTP should be here, but yeah, it should be all right in the docs. Just a tiny thing. All right. Maybe you can also explain the delay in the graceful shutdown.
Yeah, absolutely. So this was a nice feature to add. So to put things into context, let's say we have an application, that's using maybe some state store and some pub sub and things like this. It is the case that as your pod is being terminated or something like this, maybe the node is being rebalanced, or maybe your replica set is scaling down, then it's a case that even though you do receive a term signal, and you want to, and you need to shut down, it is the case that it's often the case that it's actually that you want to maintain the ability to use the Dapper API. So let's say as part of your shutdown process, you need to save some state, or you still want to process pub sub messages in flight or things like this. So previously wasn't the case to do that. So we've added this annotation, and it's a CLI flag on Dapr itself if you're running in self-hosted mode, that once you receive a shutdown signal, you can then block shutting down Dapper to keep the APIs available so you can continue to use them in whatever shutdown procedure you have. And yes, this is super useful. So the way that is configured, you can give a duration of how long you want to block for, and this would be your upper bound to block that duration. You know, so you could put it to 20 seconds or a minute or something like this, but you could also shut down faster by having your application report itself as unhealthy. And so, you know, the kind of 60 seconds or whatever you set this value to will be the upper bound, and then you can, you know, tightly control with the actual runtime context of when you want to shut down based on the health status of your application. Yeah, and it's also worth noting that during this kind of block shutdown time, Dapper will not accept any incoming requests. So things like new pub sub messages or a service invocation or something like this will not be accepted, but egress API calls will be accepted. So, you know, again, maybe you want to publish a message or save some state in your shutting down application. Yeah, you can do that here.
Cool. Yeah, I can definitely imagine that people are using a Dapper also in their own shutdown procedure of their application. So yeah, that definitely makes sense to handle this a bit nicer. Yeah. Okay, nice. Let's move on to the standardized error codes. I can actually demo this. Maybe talk about it first. So a new, let's say, richer error model was introduced. At the moment, only the PubSub and state management APIs are now using that newer, richer error model. I'm not sure if is it for all the APIs already? Do you know that, Josh?
Well, no. So
I mean, sorry, I mean for all of the languages for those two APIs.
Yes. So all of the languages will be receiving these error codes. That is correct.
Right.
Yes.
Okay. Yeah. Exactly. Yeah. Because it clearly mentions that it's only for PubSub API and state management API. So the rest of the APIs still need some work, and we're definitely looking for, of course, more contributors in that area as well. So if you want to help out with implementing this richer error model for the other APIs, please make yourself known.
Yeah.
But yeah, let's have a look indeed at this newer error model in an example. In this case, we are using a state management API here. This can go. I'm using the JavaScript here. Okay, so we're using this again. I'm using the quick starts repository JavaScript example for state management, which is like an order processor, which goes in a loop to save some state, and we use the order ID as the key. But now here I'm like purposefully introducing like an incorrect key because we cannot use this double pipe symbol because that's actually used by Dapper itself. So let's run this and see what error it gives back to us. So I need to run this. Again, I'm using the Dapper multi-app run. Okay, so here we get the error. All right, and it's pretty big, so I should let's say copy this out of it. It's a bit easier. And of course, I already created a file where I can paste this in. It was already there. All right. Let's format this. Okay, so the error message now contains much more information than before. So if we just like scroll through it, so we see like first like error malformed request, which is still not very clear. But then we see like more information, right? So we see invalid argument, and then that has a description, which mentions like very clearly here this key prefix 1 and the double pipe A can't contain the double pipe symbol. And there's even more details there on that. And the type mentions like it's a RPC, gRPC error info type. which contains even more information, and we can see the reason here. So this is like our new standardized error model now, which clearly indicates that this is like a Dapper state illegal key error. So this should be neat, allow developers to quite easier debugging, right? You can now search for this term, and it should easily pop up like, well, what's going on? The description is much better. So I think this should result in a much better developer experience when you run into some issues. All right, and yeah, like I said, only for state management and pub/sub APIs we have this implemented now, and we can definitely need some help for the other APIs to get this implemented. All right, Josh, you can probably say something more about the Dapper actor reminder performance.
Yeah, absolutely.
Involved with this.
Yeah. So previously, actor reminder state was stored in JSON format, which is very stringy and not necessarily the most compressed. That has now been changed to protobuf. Protobuf being on average far more compressed and quicker to process. You're not doing this marshalling and unmarshalling. Well, you are, but yeah, technical details. It's a better storage format, almost always. Some caveats here, though, that this is currently an opt-in feature. If you want to try this, you will likely see performance improvements if you are a large user of actor reminders. However, yes, it's not on by default. And it's also worth noting that this is a one-way door. So once you have enabled this new storage format for actor reminders, it is irreversible to go back to the JSON. So yes, please do try this if you want to try it out and see what kind of performance improvements you get. But yes, just keep in mind that it is a one-way door, and it is changing the storage format of your reminders. So yes, keep that in mind. We've left it off for now, specifically for that reason, and we'll be switching the defaults into in a further version.
Yeah, thanks. Yeah, makes sense, right? If you change the underlying format, then you can't, let's say, read the old font anymore, or if you start using it and then go back, But yeah, it's good to be aware of. So thanks for that warning. All right, let's have a look at some components now. So we have like a couple of new components. One of them is like a local name resolver based on SQLite. And I'm actually very happy with this because by default, if you like run Dapper in self-hosted mode, maybe you're just running it on a laptop for doing demos, like I do a lot. By default, like MDNS is used, but that is also often blocked by firewalls and VPNs. And it actually happened to me like a couple of times when I did like a demo at a large enterprise. The first demo that I did was like a service verification, and it would like immediately fail. So I'm happy that I can now use a different name resolver actually in a more reliable way actually than MDNS. Let's actually demo this as well. I'm going to do this.
Yeah, this makes me happy as well. Being a Nix nerd, I can run Dapper a lot more reliably, and like a Nix like small VM.
Right.
Don't need to have an MDNS service running. Just use SQLite.
Yeah, these are sort of small things, but yeah, they make a lot of lives a lot better. These small fixes, I like it.
For sure, yeah.
All right, so this is my Dapper configuration. So that's on a Windows machine, so that's under my local folder. So I mark d.dapper, and then there's this config.yaml file. It's this location. So I've added this name resolution part to it. So it says component, SQLite version 1, and the configuration just points to a connection string that points to my local SQLite database. So if you want to use this, you need to install SQLite. You need to create an empty database somewhere, and then include this configuration with the path to that database. Now then you can just run the regular service invocation samples as you would normally do. And I actually have like a viewer here on SQLite. So if I have a look at the host there, so you can see what kind of type of information is there. And so the typical Dapper example in quick starts deals with an order processor service and a checkout service. So we can see the app IDs here, and we can see where they're running and where they're at. So this is the typical information that's now stored in SQL. You never have to look into this database though, but it's thought it might be fun to show to you. Right. And let's move back to the slides or the blog post actually. All right, so for the next part is like there are for two components for the Postgres state store. There is a new version. There's like a v2, and that means there's like a breaking change, and that's because the data storage type is now changed. So it mentions here we are now storing in a field type of called byte A instead of JSON B, and this is like also again for better performance. So it allows to be queried faster, and sometimes also more space efficient. But again, as for also let's say the actor one, which also like it changes of the type of how we store the data. Since we introduced this difference of data storage type, it's only like a one-way direction, right? So if you use this v2, you cannot go back to v1. So yeah, either migrate to v2 and make sure you move everything, but you cannot like mix and match. The other v2 is for the Azure Blob Storage state store. The original version of that didn't correctly respect the key prefix setting. So you can configure a state store to use like a key prefix. So by default, it uses the application ID as a key prefix for the key value pairs that you store. But you can also set it to none, and then it actually doesn't use the application ID, so you can actually have some kind of shared state between different services. But the first version of the blob storage state store didn't actually respect that key prefix setting. So the v2 does now use it. But that also means indeed, you either have to stick with v1 or indeed start over with v2. Right, so those were like the major API changes and the major component changes and new components. Then there's been like a lot of let's say smaller component improvements, but not less important. A lot of stuff regarding to AWS. It's now using AWS IAM, for instance. So Kafka is mentioned, AWS SQS is mentioned a couple of times. A lot of better validation on the components and how they connect with their respective backends. Let's see if there's anything that needs to be outstanding here. Yeah, there's a lot of performance improvements regarding different kind of state stores. Yeah, I think those were probably the highlights. Anything else you would like to mention regarding the components, Josh?
Yeah, no, I think that's a good run through. Yeah, as you mentioned, like lots of performance and stability improvements.
Yeah, I think
which is really good to see.
Yeah, exactly. I think that was definitely the major component of the 1.13 release. I think, right? Yeah.
Mm-hmm. Yeah, for sure.
All right. I think this concludes the run through of this release highlights blog post.